video is an electrochemical cell. We have discussed earlier in the introduction to oxidation-reduction reaction that this is an electrochemical cell is a daily life encounter example of oxidation-reduction reaction. By the end of this lesson, you should be able to define an electrochemical cell and describe a typical galvanic cell. That is an electrochemical setup. But what is an electrochemical cell? An electrochemical cell actually can be described as a device that uses a spontaneous chemical reaction in aqueous solution to generate electrical current, that is, converts chemical energy into electrical energy. A chemical reaction results into producing an electricity. When we explore this concept, we are going to meet up with some terms. We have to define them separately, and we get into the concept. The flow of electricity is called an electric current. A metal strip dipped into a solution of its salt is called an electrode, which might be positive or negative. And an electric current is made up of charges in motion. So we will encounter all these terminologies in this video as we explain a typical galvanic cell. A galvanic cell is a typical electrochemical cell which is not rechargeable. We will take a look at the operational process of galvanic cell. Zinc atoms of the zinc electrode that can be seen in the right hand side dissolves into solution as zinc ions by emitting electrons from the zinc electrode. Therefore, the free electron density of the zinc electrode increases than the free electron density of the copper electrode at the left hand side. Therefore, zinc electrode is at the negative terminal of the cell called anode in this setup, and copper is at the positive terminal of the cell called the cathode in this setup. Due to the accumulation of electrons at the anode, that is the zinc electrode, the electrons begin to travel to the cathode electrode known as flow of electrons, generating an electric current. The electrons which react with the copper electrode combine with the copper 2+ ions in the solution and reduces the copper 2+ ions to normal copper. Therefore, copper electrode gains electrons and zinc loses electrons, serving as the anode, and the zinc electrode is observed to be becoming smaller due to losing electrons, and the copper electrode began accumulation of electrons and hence becoming bigger due to gaining electrons. This imbalance in the chemical reaction requires to be neutralized by another terminal. The terminal in this aspect is known as the salt bridge. The salt bridge is composed of sodium chloride. Chlorine begins to travel to the anode and sodium begins to travel to the cathode, neutralizing the imbalance where the negative ions of chlorine will neutralize that of the oxidation and the sodium neutralize that of the reduction process. Let's have a recap now. An electrochemical cell is a device that uses spontaneous chemical reaction in aqueous solution to generate electric current. It converts chemical energy to electrical energy. The metal strip dipped into solution during this electrochemical process is known as an electrode. The anode is the negative electrode and the cathode in this setup is the positive electrode. Thank you for watching.